Welcome back to The Conversation. This is the third in a series of conversations about math anxiety. We're here with Herb Gross and Sandy Shugart. I'm Susan Brown. Herb, in the last tape, we were talking a lot about math as a language problem, that people have math anxiety, but it's due more to not being able to translate math into something more familiar than it is to the math concepts itself. What about the use of calculators? Because perhaps you could reduce math anxiety altogether by just letting the calculator do all the work for it. In terms of talking about reducing math anxiety, what do you feel about calculators?
Well, there's good and bad to it. Like, as I say, I often like cartoons, and one of my very favorite cartoons, I have very many very favorite cartoons, but this very favorite cartoon shows a great big Roman slave galley, hundreds and hundreds of people rowing, chained to the oar, and the slave captain is whipping them, and the captain under the picture has him saying, "Gentlemen, I have some good news for you and some bad news. The good news is the captain has quadrupled your rum ration. The bad news is this afternoon he wants to go water skiing." Okay, so there's a hook in everything. The calculator can be used for a lot of things. For one thing, if I want to teach people critical thinking, think of how much of a math problem doing it longhand is spent just doing computation. So it may take a whole hour to do 3 problems if the computations are lengthy. If I want a person to learn to understand concepts, I might be able to get 20 problems into that same amount of time if I use the calculator.
For the computations.
For the computation. Second reason it's helpful is, especially with an older student, and it's not always related to age, but if a student is very, very nervous and they feel that the calculator is going to help them, if they've been unsuccessful traditionally for a whole bunch of years, why guarantee one more failure by having them go in just as anxious without the calculator as a helper? See, the point is the calculator won't help you in certain situations. You see, I guess, and this applies to society also, and if we look around us, we can see a lot of this going on. The only thing worse than the wrong answer to the right problem is the right answer to the wrong problem. Or to put it another way, the most wasted job in the world is the job well done that shouldn't have been done in the first place. Okay? Now, let me give you an example both on the teacher's part and the student's part that leads to a problem. I have had teachers say to me, how can we test kids in subtraction if we give them a calculator? In other words, what the teacher says, if I write down 7 minus 4 equals blank. The teacher says, if I give the kid the calculator, he's going to put in the 7, the minus sign, the 4, the equal sign, and the answer is going to light up over here. Well, see, from my point of view, all you have to say to the student, what do we add to 4 to get 7? Now, if you, when I was a kid in school, this is a true story, teacher says you can always tell when it's going to be an addition problem. They'll say and, or they'll say add, and kids clue in on that. And those are dangerous clues, because you see, what will that kid do in this case? Let's look at the sentence again. What do we add to 4 to get 7? What are the buzzwords here? Add, 4, 7. And if I add 4 and 7, the answer is going to be 11. Will it be 11 that way if I use the calculator?
Yes.
Yes, yes. See, the point is...
You've got the right answer to the
wrong problem. Sure. And this kid will say to me, are you sure you used to teach math at MIT? I said, why? He said, well, how much is 4 and 7? I said, 11. He said, well, you marked it wrong on my paper. See, they don't hear the right question that way.
Right.
And so that can be a very dangerous thing. So you see, by the way, you see what's happened the way I've worded this question? A lot of people say to me, yeah, but now they have to be good in language. What is the single greatest problem we have right now? It's not math, it's reading comprehension. And a problem like this not only allows the student to use a calculator, but it forces the student to use comprehension. You can do many operations. I remember one of my favorite jokes. I hope this is not in bad taste because I think it's in a proper environment. It's a story of the geography professor who goes into class one day and he says to the students, I have a very hard question for you. He said, if we're bounded on the north by Canada, on the south by Mexico, on the east by the Atlantic Ocean, on the west by the Pacific Ocean, how old am I? And nobody knew except one kid. He raised his hand and says, Professor, you're 42. Professor, that's amazing, but how'd you know? He said, it's simple. I have a brother in a mental institution who's 21, and you're twice as crazy as he is. Now see, 21 times 2 is 42. The kid happened to be right that time. The next year, the same logic is going to give the wrong answer, because the next year, the brother will be 22, but the professor will only be 43, he won't be 44. So there's an example of you know, just because you shuffle numbers doesn't mean that something good is going to happen. In fact, just coming in to the studio a couple of days ago, one of the talk shows was going over an old chestnut that comes up almost every year in one form or another. It's the story, maybe you've heard it, it's an old chestnut, of the three men who go to a hotel. You can tell how old this story is by how much the hotel room cost. The three men go into the hotel, and the room clerk says the room is going to be $30. So each man gave $10 to the room clerk, and they went to the room. Afterwards, the room clerk checked the room rates and saw it was only supposed to be $25. So he gave the bellhop $5 and said, would you please return this to the gentleman who just checked in? Well, the bellhop hadn't seen our first two lectures. He was bad with fractions. He didn't know how to divide $5 by 3, okay? But he figured, hell, this is a great situation. These guys aren't expecting to get anything back. So what I'll do is I'll give them each back $1, because that's easy for me. And I'll keep the other 2. So the story, the riddle goes like this. They originally paid $10 each, right? Each man got back $1. That means they now each spent $9. 9 threes are 27. 27 and 2 that the bellhop kept is 29. What happened to the other $1? Inmates are still looking for it, okay? Let's just write that problem down and see if we can see the truth of this. Let's take a look and see what happened here. They each spent $10. They each got back $1. Let's check the math here. They each got back $1. That means they each spent $9. Let's see if anything is wrong here. $9 times 3 is 27, and 27 plus 2, which is what the bellhop kept, is 29. Is there any mathematically incorrect statement on this page right now?
Not mathematically.
Not mathematically.
So a calculator would do it just the same
exactly,
way.
Exactly the same way. Now, obviously, I hope we all realize nothing happened to that extra $1. Let me now paraphrase that question. Somebody says, how much money did that cost you? And I say to you, gee, I don't remember, but I remember this. I gave the clerk 3 $10 bills, and he gave me back 3 $1 bills. Any math anxiety there? And how much money did I spend? $27. I didn't spend $30 because I got the change, didn't I?
Right.
What happened over here? They each gave a $10 bill. They each got back $1. How much did they spend? 9 times. Yeah, 27 is the total amount they spent.
2 of that went.
2 went to the bellhop. In other words, what should be done over here is it's true that 27 plus 2 is 29, but in this problem it should be what?
27
It's a
minus.
minus
Yeah,
2.
sure. They spent $27, of which 2 went to the bellhop and 25 went to the room. You see, and the calculator isn't going to solve that kind of a problem for you. See? So that is one of the problems that we do have this way. In other words, you give the, and in fact, I don't think this is a bad idea. If a person thinks that they can solve a problem using a calculator, give them the calculator. And one of 2 things will happen. Either they will solve the problem using the calculator, in which case it's fine, they were right. Or what will happen? They won't be able to, in which case they'll realize they made the mistake. That's a very, very important
But you took
thing.
away the excuse.
Exactly. You know, it's a very, very important thing in terms of dignity. Don't say to a person, you can't do that, or it's legal, but I'm not going to let you. That shows them that your values are more important than theirs. What you have to do, in fact, I have a talk that I give when I speak at International Correctional Education Association meetings, and it could apply any place where you're teaching disadvantaged students. And the title of the talk is called No Risk Education for High-Risk Students. And basically what it says is, when a student is at risk, they will look for any excuse to drop out. I don't like to sermonize. Actually, I like to, but not on camera. But it's a very, very important thing to me. You see, what do you think happens to a person who's petrified of something but is too proud to drop out? That can cause a mental breakdown. So the way you survive is, again, by rationalization. You hope that somebody puts an obstacle in your path so that you can use that obstacle as an excuse.
Right.
In other words, if I said to my students, I want you here punctually at 9 o'clock, and if I lock the doors at 9, and anybody who's not in here at exactly 9 gets thrown out of class for good, I have 15 students who would show up at 1 minute past 9 with witnesses and say, see, I was here, and he wouldn't open the door. You see the idea? So let me give you an example of a kid who says to me, in the real world, we can use a calculator. And by the way, let me point out, in my course, I do allow them to use the calculator, but only after the 8th chapter of the arithmetic course, because the first 8 chapters review arithmetic. I'll talk about that in a few minutes too. But I do let them use the calculator. But suppose the kid wants to use the calculator before that. I could say, no, no, you can't use it till chapter 9. I say, you really think the calculator is going to help you? He says, sure. And so let me just jump ahead into something that if you have math anxiety, probably you'll see what I'm driving at. If you don't, you'll also see what I'm driving at. I'll give like 3 problems to the student. I'll say 30 is blank percent of 60. That's the first question. Second question will be 30% of 60 is blank. And the third question will be 30% of blank is 60. By the way, these happen to be 3 completely different questions. And in case somebody is nervous about what the answer is, 30 is 50% of 60. See, 30 out of 60 is the same, it's half, is the same rate as 50 per 100. 30% of 60, if you're taking 30, we won't get into this in too much detail. By the way, 30% means 30 out of every 100. 30 out of 100 is less than the whole thing, isn't it? Therefore, even if you had a calculator that didn't know what to do you at least have a hint that the answer has to be less than 60? And since 30 out of 100 is 30 for me, 70 for you, that's less than half. That the answer not only has to be less than 60, it has to be less than 30. That's what I call a number sense, see? Now, 30% of what number is 60, that number would happen to be 200. Okay. Now, by the way, if 30% of a number is 60, 30% is less than the whole thing, isn't it? So if 30% of a number is 60, the whole thing must be more than 60. So if you confuse these 2 problems, if you had number sense, that would tell you what kind of a mistake you've made here. But most people don't have that number sense. But let's go back to this little problem now. What do you think the average student says to me when I give them these 3 problems? Can you guess?
They probably say they're all the same.
They look the same to me. So now I play the jilted lover. I say, you jilted me yesterday for this piece of transistorized trash called a calculator. And now you have a lover's quarrel, you're going to come back to me? I don't say it that way. Actually, I do, because they know I'm joshing when I talk that way, right? See, I say, tell your calculator. Give it the true test. Tell your calculator to do this for you. Can they get the problems down with the calculator? No. Here's the exciting thing. The first step, whether it's in prison or out of prison, the first step towards correction is that the person being corrected has to know that they're wrong. See, this student now says to me, I can't do these problems even with the calculator. The student may not care, but does he at least know now that the calculator hasn't helped him? What do you think would have happened to that same student if I didn't allow him to use the calculator?
And he would have been able to say, well, I could have done it, except he wouldn't let me have
He
a
wouldn't
calculator.
have had, sure, I got the same 3 problems wrong, but I could have done it with a calculator. You know, there's a saying when it comes to lending money, which I think is very nice. It says, never lend more money than you can comfortably afford to lose. And that way, see, the problem is what? If you give away more money than you can afford to lose, if the person doesn't pay you back, you feel kind of upset by that, to put it mildly. Okay? See, what's nice about giving away less than you can afford to lose is you forgive the person. So never give away more of yourself as a person than you can comfortably afford to lose. But most of us can afford to give away more than we really do. What's the big hardship in saying to the kid, okay, use the calculator? See, but if you don't have high self-esteem, you say, my God, he got around my rules. He used me. Well, I want my inscription to say, he was used. I don't want to die brand new. If you have high self-esteem, you're supposed to be used. But that's just one small example that way. Now,
it seems like what you're pointing out here, Herb, to tie it back to the previous conversations, is a calculator is useful for solving the problem in the language that the student's already translated. So if you simply apply that calculator to go from step 1, that is getting the problem in the language of math, to solving it at step 4, and you haven't translated it into your own language to solve the problem, then you're just as likely to get a wrong answer as you are a right answer.
That's right, that's right. And what's even worse is, if you don't understand what a right answer is, how can you tell the wrong answer is illogical?
Yeah.
So I just thought of another analogy, if we want to bring in modern technology. I would say that the calculator is to arithmetic, well, I would have said originally, what the typewriter is to writing longhand. You don't use a typewriter in place of writing longhand, see, as a substitute for it, but once the person knows how to write, okay, they can use a typewriter, there's nothing wrong with that. But now I'd go one step further, and I would say The problem with a calculator would compare with the problem of using spell check on a word processor. See, for example, suppose I wrote down, I want to buy that shirt, and I spelled that, T-A-H-T. Spell check will pick this up, right? But suppose instead of typing buy, B-U-Y, I typed that B-Y. I just forgot and left the U out. Will spell check pick that up?
No.
No, because it's spelled correctly. See, in other words, just because the words are spelled right doesn't mean that they make sense, okay? So we won't worry about that part. That we'll do in the next lecture when we talk about logic. In other words, that just because something makes sense mathematically doesn't mean that it's logically correct. But let's go back to spelling that, T-A-H-T. Okay, let's just take a look at that. Could you tell from context that I probably meant T-H-A-T over here? In other words, if you saw a sentence like this.
Sure.
By the way, spell check can't, even if it wanted to. I mean, the way spell check tells you that the word is wrong is it doesn't recognize this. See, and it would
Regardless
just
of the context.
yeah, it does
Right.
not compute. It does not compute. Danger, danger, Dr. Smith. It does not compute. Okay. See, okay, but suppose you wanted to type 321, and you now transpose digits, and you got 123. Will that make a difference in the problem?
Yes.
Will the calculator reject 123 and say, warning, warning, you wanted 321?
No.
No, see, you made the same transposition here that you made here, but at least spell check will tell you this. The calculator won't. The calculator is too obedient. It just does exactly what you tell it, provided it can do that. And that's another reason why you need a number sense. For example, we haven't talked that much about decimals, but suppose I were to say to somebody, what is 3.14 times 2.7? Let's suppose I gave a person a problem like this. Now see, what I'm saying is, we learn things that say, remember how you taught to do this? I won't even do this problem because it may scare somebody. Well, let's do it, to heck with it. It's 7 times 4 is 28, carry the 2. 7 and 2 is 9. See, what's nice about the new math is the method that's important, not the answer. 7 times 3 is 21. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Then we add this up, 8, 7, 4, 8. And then we were taught what? Count the number of decimal digits to the right.
Right.
1, 2, 3. Then you start over here and count back 3.
Right.
Okay, and by the way, the adjective noun thing gets around this. You see, this looks like a decimal, but without the decimal point, it's 314, 2 zeros, hundredths. 314 per 100. That means it's more than the whole thing, and 3.14 is more than the whole thing. But let's not get into the math. That's a different issue. But here's what I'm saying. Suppose you punch this into the calculator incorrectly. Or suppose what you did was you thought you were entering 2.7, but unbeknownst to you, I like that phrase, unbeknownst, you typed in 27. You didn't press the decimal point hard enough. So now the calculator is going to give you what? 84.78. Now, if you have no number sense, you look at this thing over here and you say, well, calculators don't lie. But here's what I mean by number sense. What two whole numbers, see, think of it in terms of money, $3.14. It's certainly more than $3, but less than $4. Let's disregard this thing over here. 2.7, see, it's 2 and 7/10. 2 whole units and 7 of the 10 that you need for the next one. That's certainly more than what? 2, but less than 3. Now, again, this is not higher mathematics. 3 times 2 is 6. And that's too small to be the right answer. 4 times 3 is 12. See why it has to be too big? Because the 4 is bigger than this, the 3 is bigger than this. This is called a lower bound and upper bound. And by the way, doesn't that come up in the real world a lot too? In other words, when you want to consider something, I talk to the inmates about this too. Whenever you have something to consider in real life, isn't there a best case and a worst case? If best case is awful, why even bother trying? And if worst case is great, why not? See, so in mathematics, what we call upper bound and lower bound corresponds in everyday life to worst case, best case. And worst case, best case is a great form of critical thinking. Whenever you want to undertake something, say, what is the worst that can possibly happen to me?
Right.
Or what's the best that can happen? Many people never stop to think about that step. They just plunge before. But let's go back to this now and take a look and see what this does for us. See, what do we now know? We know that the right answer has to be
More than
Somewhere
6.
between
between 6 and 12.
12.
Well, there's lots of numbers between 6 and 12.
But 84 is not one of
But
them.
84.78 ain't one of them.
Right.
See, so in other words, I have now discovered something that's really remarkable as far as I'm concerned. You see, what I've done is, without even knowing what the right answer is, I've been able to determine an answer that isn't right.
Right.
So you ever hear people in society say, well, if you don't know, if you don't know the right answer, what are you belly aching for? See, I don't have to know the right answer to be able to recognize an unreasonable one. Suppose I'm a kid who's only eaten carrots. I've never tasted peas in my whole life. I've eaten carrots and I don't like them. So one day I say to my mother, I want peas. Why should she say to me, what do you mean you want peas? You never tasted them, you damn fool, eat your carrots. What she should say is, he's never eaten peas. So what he really means is he doesn't like carrots. And now that she knows something that she didn't know before, she'll give me broccoli and tell me it's peas, and I'll know, I'll say, great.
What difference? Yeah.
See, what
Doesn't
difference?
matter,
See, so what I'm saying is, look what's happened now. In other words, it's much easier to know what's wrong than to know what's right. And I'm saying here, math is a great place for teaching that. In other words, you don't think of a computational math class as a place where you're going to teach about society, about values.
About
and the
limits.
like. Sure, limits, upper
Boundaries.
bounds, lower bounds. Look, this is a dull, hand-calculated discussion type of thing. Look at all the things we can generate this way. See, rounding off, making estimates. If you have a number sense, in other words, language problem again. If I were to say to a student, if there were 2.54 centimeters in an inch, how many centimeters are there in 10 inches? The student says, I never had the metric system. Okay? If I say to him at $2.54 a pound, how much will 10 pounds of ground beef cost? He never says to me, I never had the ground beef system.
Right.
He just says, I'll just take 2.54, modifying dollars in this case, and multiply it by 10.
Right.
He doesn't see that mathematically, that's the same question, you see. And by the way, another thing that he could do is, suppose he now knew that it was 2.54 times 10. And of course, multiplying by 10 is kind of easy. Most people know how to do this mechanically by moving a decimal point. But I'm pretending I don't know that. In terms of whole numbers, is it very hard to know what 2 times 10 is?
No.
It's 20. And how hard is 3 times 10? 30. And therefore, 2.54 being between 2 and 3. The answer has to be where?
Between 20 and 30.
Now, it's kind of funny because we almost teach that in Goldilocks and the Three Bears. It was the Grimm brothers' answer to what we call numerical analysis in mathematics. See, in mathematics, when you want to solve a difficult problem, you really take a guess. They tell you not to guess. Mathematicians guess all the time. You guess an answer. If it turns out to be too small to be right, you try something bigger. If it's too big, you try something smaller. I call that the Goldilocks and the Three Bears syndrome. What did she do? She sat in the father's chair, that was too hard. Sat in the mother's chair, that was too soft. Baby's chair was just right. In other words, when you use this upper bound and lower bound thing again, see, it becomes a lot easier. In other words, when you say things like, there are 2.54 centimeters in an inch, after you get through the centimeters per inch bit, suppose you say, well, wait a second, suppose there are only 2 centimeters in an inch. Then in 10 inches, there'd be 20 centimeters. And if there were 3, there would be 30. And since 2.54 is between 2 and 3, the answer is somewhere between 20 and 30. Do you ever notice in real life that the only important thing is to come close? You don't have to get anything exact. That's why I love multiple choice versus subjective type of questions. I think that's one of the reasons why kids score high on multiple choice exams, because you can teach them how to take the exam. It's like Louise came home one day, said, any phone calls for me? I said, I'm going to give you a multiple choice question. You got a phone call from A, the President of the United States, B, the Director of Public Instruction for the state of North Carolina, C, your mother. And right away she knows who it was. But if I said, guess who called, she doesn't know. See, so again, you see what I'm driving at. The calculator can be a tremendous help to a student. It can also, in fact, I think using the calculator can force people to become better at critical thinking. Because, you see, this happened, by the way, truthfully, in engineering. When the computer came in, many engineers who had been faking it now lost their job, because what used to happen was they would say things like, I'm on the verge of getting the right answer, but the computation is so complicated, it's taking me longer than I expected. So we get pages and pages and pages to do. Now the computer came out and did the problem in seconds. So if you didn't understand the concept, you see. But by the way, the reverse has happened in mathematics. The subject called differential equations has now had a complete renaissance due to the computer, because what happened was there were many methods called the Bell's method, Picard's method, methods that came up in the 19th century that were very, very precise but tedious.
Right.
And it took a long, long time to be able to, what would happen is you sit down and it would take a long, long time to get the answer. Now, with the computer, once you put the generic formula in, the computer grinds out the answer in seconds. And here's a wonderful example of technology allowing great ideas from the past that had become too cumbersome, not incorrect. They were not used because they were cumbersome, not because they were inadequate. And all of a sudden, they weren't cumbersome anymore. And you see, this also applies to teaching. See, in the old days, if I had a very novel way of teaching, people would say, Herb, that's great, but what if you drop dead tomorrow? Hardly a pleasant thought, okay? But see, I didn't have an answer in those days, because who's going to take over? Now all I say is, tape me today. Tape me today. As I said to Susan, I can teach posthumously. And she says, wonderful, the sooner the better. No, but you see what I'm saying? Can I be in 1,000 different places at the same time now on videotape?
Sure.
Sure. Can I do things with the calculator that we couldn't do without the calculator? Sure. Can I give the kid more problems to do because the calculator takes care of this part? I think it's pathetic, though, to go into a supermarket when there's a power failure and watch that poor kid behind the counter trying to make change.
Right. Who's using a calculator all day?
They were using a power calculator, and now the power calculator went out.
Yeah.
And so I think that's the good and the bad, the why and the why not, right there.
So you'd say that to the extent you use a calculator to support the kind of critical thinking that goes into doing math,
Sure.
the calculator is a useful tool. To this extent you substitute the machine for critical thinking,
Right.
it's in the way.
And to the extent that you can let the student retain his dignity.
Of course. And how many 5-digit numbers do you have to multiply together before you're sick of it?
Not very often.
We'll continue.